This conference will now be recorded.
So good evening, students. Today we'll start a new chapter entitled as waves. So we know more or less from the previous chapter what we know that if some object oscillates to and fro or harmonically, it will actually produce a wave. Okay, so that we know. And waves we know, if you go to the beach, sea beach, you'll see there are waves in the sea water, but it is very tough to understand various natures of the waves from there. We'll take up a very simple and common example. All of you might be having this experience. Suppose, actually we are going to now define what is a wave. What is a wave? So wave actually is a kind of disturbance. A kind of disturbance. Wave is a kind of disturbance. Okay, which propagates. We'll define formally, but let us first understand from our practical experience. If we just throw a pebble in calm water of a pond, we see such kinds of rings or circular or general. The point of impact, this is the point of impact. Okay, this is the point of impact, and from there circular patterns like this will propagate. As you see here, see, these are the circular patterns. Okay, these are circular patterns. This is one pattern. Okay, this is what, and another pattern is this one down. This is also one pattern. So you can see what happens here. The water molecules, after impact, there will be circular patterns generated, and those circular patterns will be propagating from the point of impact to the end of the pond, or up to shore sometime. Okay, it will come up to shore. So what we see generally, what happens here, see, after the impact, the water molecules, some of the water molecules, they vibrate up, and some of them will vibrate down. So water molecules are vibrating up and down because of what? Because of this disturbance. Earlier, the water was calm, water molecules were not vibrating at all, they are still. Okay, they were still. But when the pebble is thrown, then after the impact, there will be circular patterns generated. Some patterns are actually like this, and some patterns are like this. What is this? Actually, water molecules are vibrating down or moving down, and here water molecules are moving up. So this is what happens, up, down, up, down, like that it happens. So what is happening? Actually, there is a disturbance created by this pebble on the calm, like in the calm water surface, and because of that disturbance, the water molecules are vibrating, or water particles are vibrating ups and downs. You might be thinking, we may assume that the water is moving from that point to the other point. Okay, maybe we may think that water is moving. We may think that the water is moving, but to examine whether the water molecules are moving or water as a whole is moving from that point to the shore, or away from that point of impact or not, if you just drop a cork, okay, which is a very light one, which can vibrate with this vibration, and it can float. So by seeing the motion of this cork piece, or a paper also, light paper you can give, so you can just track the motion of this and understand whether the water molecules are moving or not. If water molecules or water itself would have moved from this point to this way, then this cork would have moved from that point to other point. But surprisingly, we see that this cork doesn't move. It is just moving up and down, up and down. That is what it is doing. It is not moving forward. Okay, it is not moving forward. So what we can understand, something is propagating forward. Something is propagating forward. What is that? That is the disturbance. That is the disturbance moving forward. Disturbance. This is a disturbance which is moving forward, is moving forward, but not the water particle. Water particle. Water particle is not moving as a whole. What is moving is the disturbance. So actually, if you take a pebble and throw it, it has some kinetic energy. Pebble has kinetic energy, and that kinetic energy is actually transferred to the medium, to the water particles. And taking that energy, water particles actually move up and down. Okay, actually energy is propagating, and the disturbance which created here, which is created due to the impact with the calm surface of the water, that disturbance is moving forward in all direction in this case. But water as a whole, or the medium through which the disturbance is moving, that is not traveling or moving at all. Now we are in a position to define what is called waves. So waves is kind of a disturbance. Like, see, when we speak, then also disturbance is created. So we speak due to the sound wave, whatever we listen, sound. So sound is a kind of wave. That is also disturbance. Okay, that is also disturbance. That disturbance is different kind. We'll discuss that as we go along with this chapter. So sound we produce by vibrating our lips. Okay, vibrating the air near our lips. Okay, so that disturbance, so we disturb the air column. We disturb the air column. Even in our vocal cord also, there is a diaphragm which actually vibrates, due to which sound produced. Sound is actually a wave. Wave means a disturbance which travels through elastic medium. Sound wave is a disturbance which travels through air, okay, or any other elastic medium, okay. So the disturbance actually, the disturbance we produce while speaking is not that great that you can see, just like air, yes, just like water wave we have created here by throwing a pebble. Since we cannot see air, the disturbance also we may not be able to feel, but this disturbance can be felt by microphone or other technical devices which can sense or detect this disturbance. That's why, see, even in sound recorder, etc., they can feel it, okay. So now we'll define what is wave. So wave mm, so what is this wave doing? Wave is actually moving, so that is called the motion of the wave. So wave is a disturbance which can travel from one point to the other. So what is wave motion? What is the wave motion? Wave motion. We'll write what is wave motion. So wave motion is a kind of okay. So wave motion here, actually the disturbance travel through a medium. The disturbance travels through a medium. So wave motion is the disturbance or motion of the disturbance is the disturbance which travels through a medium due to repetitive vibration of the particle of the medium about their mean position. Okay. So in this case, two things are actually propagated. One is the disturbance, that is the wave, disturbance, and another one is the energy energy also getting transmitted from one point to the other point of the medium. So you can see how it is, how the wave or disturbance travel. See, there are particles all over, right? Water particles all over. So when one particle gets disturbed by this impact, then it actually oscillate about their mean position, and by that way actually it also disturb other particles. That means it actually transfers the energy from itself to the nearby particle, and then nearby particle starts oscillating. Okay, and it also will transfer the energy to the next particle, and next particle will transfer the energy to the next to that. Like that, the particles oscillating about their mean position, and as one particle oscillate, it will induce the other particle to oscillate, and that's how the wave travels. So as I was saying you here, some of the water particle moves up, some of them are moving down, right? So the particles which are moving up like this, so some water particles are moving up and some are going down. Some water particles are going down. So this is the way the particles moves, and because of that the disturbance travels in the forward direction. So this point or these particles which are moving up are called crest. This is called crest, and this one is called trough. 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 So the particle, when the particles are oscillating in the downward direction, this is upward direction, so crest and trough. So this is crest as you see from here, and this particular part is actually trough. So when there are one crest and one trough, it will constitute a complete oscillation, or it will complete the oscillation of the wave. Okay, when there is a crest and trough, there will be one crest and one trough. I'll draw here. So this is a complete wave. This is called a full wave. Full wave. So here this is trough and this is crest. So to constitute a full wave, there should be two, like one crest and one wave at least. So that will create a full wave. Okay. So as I said, energy transfer happens, and due to that, one after another, material particle or the medium particles are oscillating ups and downs, and that's how they respond to the impact, okay, or to the disturbance. And as I was saying, that the water particles do not move from one point to another. They will actually oscillate at their same position, but they will not move forward or backward. Okay, so we'll now learn few characteristics of wave motion. Actually, when we speak through telephone and all those things, there is a complicated process to transfer the sound wave. We are producing sound wave. That will be, so sound wave will be first converted to electrical signal. Then that will be converted to optical signal. Then optical signal will be transmitted through optical fiber. Okay, and then when the destination is reached, the optical signal will be actually converted to sound again. Okay, so this is how there is a complicated system involved, or complicated technology involved in communication system. We'll learn, actually we have already learned in the 12th chapter of that, not 12th, I think 14th 15th chapter of 12th standard. So in 12th standard we have learned communication. You will be learning also communication system. So there it is given in detail. Okay, so now first we'll see few characteristics of waves, then we'll see the classification. We'll first see characteristics of some waves, like all the waves, not some waves, some characteristics of waves. So first point is, in wave motion, disturbance travel through medium due to repetitive periodic oscillation of particles of the medium about their mean position. So this is characteristics of wave motion. So disturbance travel travels through the medium by repetitive or repeated periodic oscillation of medium particle, or the particle of the medium, particles of the medium. Second point is that energy transferred from one place to another without any actual transfer of the particle of the medium. So energy transfer happens, energy transfer occurs without physical transfer of medium, physical transfer of medium. Then third point is, each particle receives disturbance at a later point compared to the previous one. That means there will be a definite phase difference. There will be a definite phase difference between one particle and the next. What does that mean? Okay, so what does that mean? Suppose there are water molecules throughout. So when this particle moves up and down, there may not be any disturbance reached to the next one. After this starts oscillating, then only it will start oscillating. So suppose uh, a particular wave had started at t is equal to 0. At t is equal to 1, a particle is oscillating, and t is equal to 2, another particle is getting that oscillation. So actually T2 is greater than T1. T2 is greater than T1. That means this particle P2 is oscillating after the first one. P1 oscillates. So that's how there is a phase difference between the oscillation of the particles. Okay, there will be a phase difference. Now there are few more points about the oscillation. So velocity with which the wave travels, that will be different. Velocity of waves will be different from excuse me, velocity of the wave will be different from the velocity with which particle oscillate. With which particles oscillate. That means, so this is actually particle velocity and the velocity of wave. See, wave velocity always will be constant, but particle velocity will be different from its position. Do you remember? In oscillation, velocity is maximum at this point, the mean position, and that will be different from the particle velocity. So you look here, see particle velocity at each point there will be different velocity, and at this point it is maximum. Okay, so particle velocity may change, but velocity of wave, so velocity of wave doesn't change. Okay, these are the fourth. So another point is that the medium in which the wave propagates, so medium has to be medium has to be elastic, then it has to have inertia, and it has to have minimum frequency, sorry, friction, minimum friction. minimum friction. So these are few characteristics. So you have to understand among these uh, the most important point is that the disturbance always travel, but the material particle does not. There are two velocities. One velocity is the velocity with which the wave travels or the disturbance travels through the medium, and another velocity with which the particle of the medium oscillates ups and down, that velocity. There are two velocities. Okay, so they are not same. And here energy transfer happens. Okay, so these are the few points which we should remember. And the last point is the actually telling you the nature of the medium which can which can actually act as the medium of the so these are, see, elastic medium has to be elastic, then it has to have some inertia so that it can store kinetic energy, and it should have minimum friction, so there because due to friction there will be loss of energy. So these are the points. Now we'll discuss the classification of waves. So classification of waves, there are two different types of classical classifications. Here the classifications we are doing first in terms of their nature of vibration and their production and their propagation. Nature of those actually divides various type of motions into three main categories. So waves, different waves can be classified into three main categories. What are those? First one is mechanical wave. Mechanical wave. Then second is electromagnetic wave. Electromagnetic waves, and third one is the matter wave. Matter wave. So these are actually three different types of waves. We'll discuss each of them separately. What is called mechanical wave, what is called electromagnetic wave, and what is called matter waves. We'll discuss it soon. Just a minute. I just need to drink some water. I'll resume in 1 minute. Yeah, so I'm back. As I was discussing, any wave you take, we can put that wave into one of these three main categories. One is mechanical wave, electromagnetic wave, and matter wave. So what is a mechanical wave? Now we'll discuss one by one. So first one is mechanical wave. So these waves require a material medium for their propagation. So that's why these waves are called actually mechanical waves. So waves which require a material medium are called, okay, material medium for propagation are called mechanical waves. Okay, so there are few characteristics of this. See, such waves are called elastic waves also. Such waves are called elastic waves also. Why? Because their propagation depends on the elasticity of the medium. Like, I'll just give you one simple example of elastic media. Elastic medium, suppose a spring. This is elastic spring. You might be uh, remembering this spring. So when you will see in the spring model, so this is kind of elastic object. Okay, so you can just compress up to here. Okay, that compression actually will produce a restoring force. So in an elastic medium, when you stretch or compress the elastic medium, it will actually create a restoring force. That restoring force will help the springs or elastic medium to regain their original form or size or shape. So that is required for the propagation of mechanical wave. So that's why they are called elastic wave. And actually, we'll see the waves are governed by waves are governed by Newton's laws of motion. Newton's laws of motion, mechanical laws. Okay, laws, Newton's laws of motion we have learned in the mechanics part. So waves are governed by Newton's sorry Newton's laws of motion. These are few important points to be remembered here. Okay, see, we can give some example like water wave or water waves, then waves in any elastic material, elastic medium, material, then sound wave. These are actually mechanical wave. Mainly, mechanical wave involves with this material medium. Okay, by the oscillation of the material particle, the sound wave propagates. Sorry, the mechanical wave propagates. So mechanical vibration is required for mechanical wave to propagate. So that's why it is called mechanical wave, like water wave, sound wave, okay, etc. All right. So this is mechanical wave. We'll see now what is electromagnetic wave. This is very interesting. You learn it again in the 12th standard, electromagnetic wave. So electromagnetics are very, very interesting. They don't require, as such, they don't require any material medium for their propagation. So what is this wave? Actually, electromagnetic wave are electromagnetic waves travel. Let me just tell you one thing here. Actually, electromagnetic wave has oscillating. Electromagnetic wave has oscillating electric field which is denoted by E. Oscillating electric field. Electromagnetic wave consists of oscillating and oscillating magnetic field. Magnetic field. Magnetic field. So oscillating magnetic field produces oscillating electric field, and oscillating electric field in turn produce magnetic field. We'll see in the electromagnetic wave chapter. Even before that also we'll learn. So there are two kinds of oscillating fields. One is, suppose this is x direction, this is y direction, this is z direction. So if the wave is propagating in this way, z direction, then one of the field will oscillate along x direction, another field will oscillate in the y direction. But actually wave will travel in the direction perpendicular to both x and y axis. Suppose this is electric field, this is magnetic field, then electromagnetic wave will travel in the z direction. Okay, we can see actually k is equal to e cross h. So x cross, like I cap j cap will be k cap, i cross j, I j k, so it will be positive along positive z direction. And for propagating of such kind of waves, you need not require any medium. I'll give you an example of electromagnetic wave, like a radio wave. Does it require any medium? No. Light, the most splendid thing. or because of which we can see around us anything, that is the light. Light is electromagnetic wave. So electromagnetic waves do not require medium for their propagation. Propagations, okay? So it consists of oscillating. It consists of oscillating electric and magnetic field. Electric and magnetic field. Okay. So that's why this is actually called non-mechanical wave also. Non-mechanical wave. Waves also. So they can travel in vacuum. Travel in vacuum, we can give you an example. The light. Light does not require any material medium. That's why light from sun is coming from all the way through the interstellar spaces which are vacuum. And what is the speed of light? Speed of light in vacuum, vac. Actually, this is denoted by c. Velocity in free space or vacuum is denoted by c. So it is 299,792 and 458. I hope, yes, 458. So this is the typical velocity, and it is nearly, we say, nearly equal 3 into 10 to the power 8 meter per second. So light has speed or velocity in vacuum or in free space or in air, it is said, that is 3 into 10 to the power 8 meter per second. Now we'll learn what is matter wave. What is matter wave? See, we have like subatomic particles. Particles like electrons, protons, then alpha particles, neutron, deuterium, etc. These are subatomic particles. When subatomic particles like these are in motion, since these are all charged particles, when they are in motion, I'm sorry, not only charged particle, electron, proton, or any fine particle like say neutron. Neutron is not a charged particle. Even I should write here neutron. So neutron, when they are in motion, etc., and in motion, produces matter wave. So matter waves are not actually matter waves. Matter waves are not the EM wave, electromagnetic waves. So the wave associated with microscopic macroscopic particle or subatomic particles such as electron, proton, neutron, atoms, etc., when they are in motion, are called matter wave. Actually, they don't produce. I'm sorry, they don't produce. Okay, let me write in good language. So the wave associated waves associated with the waves associated with the subatomic particles or microscopic particles like electron, proton, particles like electrons, protons, positron, etc. Right, proton, neutron, etc. The waves associated with the microscopic particle when they are in motion. When they are in motion, okay? And such kind of wave is, as like see, we see in electron diffraction, we'll see electron diffraction. Electron diffraction, there is one natural phenomena. Okay, electron diffraction. In electron diffraction, we need to consider the wave associated with the electron. See, in electron microscope, the waves associated with the electron is being used. Okay. So these are matter waves. I think we'll stop it here for today. It is already 7 o'clock. So next day we'll try to learn how mechanical wave propagates through material medium. We'll take one analogy with spring model propagation, and we'll learn tomorrow transverse and longitudinal wave. We'll try to understand from the demonstration, practical demonstrations, which are discussed in the textbooks, etc. Okay, so bye for today. Thank you for your patience.